Hi my dear students, welcome to DNA Education. Today we will be discussing the first chapter of Science, class 10th. The chapter is Chemical Reactions and Equations. Students, what happens when you add lemon water and sugar to water? Yes, you get lemonade. And what happens when you add little bit of curd to milk and keep it overnight? You get curd. So that means sometimes when we add a substance to another, a third substance can be formed. This is a chemical reaction. So now if we want to define chemical reaction, we may define it as when two or more substances react and form new substances. It is called a chemical reaction. Let's take a few more examples here. When we burn a magnesium ribbon, we see a white dazzling flame. This happens because of the formation of magnesium oxide, which is white in color. So in this reaction, oxygen from the air reacts with magnesium and forms magnesium oxide, which can be identified with a white dazzling flame. Here a very important point has to be remembered, that the magnesium ribbon, before conducting this experiment, before burning, magnesium ribbon needs to be thoroughly cleaned with sandpaper. And why is it so? Because magnesium metal reacts with atmospheric oxygen and forms magnesium oxide layer, which is a very stable compound, and this layer stays on the magnesium ribbon. So this MgO or magnesium oxide layer needs to be removed before we conduct this experiment. Another example of a chemical reaction is when you add sulfuric acid H2SO4 in a zinc sulfate granules containing flask or a beaker. The beaker becomes hot and hydrogen gas is produced. So what happens in this reaction is that sulfuric acid and zinc reacts to form zinc sulfate, which causes the beaker or flask to heat up. Okay, so next example of a chemical reaction is when you combine potassium iodide and lead nitrate. The particles combine and create two new compounds, which is a yellow solid called lead iodide and a white solid or precipitate called the potassium nitrate. So we saw that in such a reaction, precipitates are formed. So students, we saw that a chemical reaction leads to some changes, which can either be a change in color, a change in state, that is from solid to liquid, liquid to gas, or solid to gas. Heat can be produced or absorbed in a chemical reaction. And of course, there is a change in temperature. A chemical reaction can be written down or represented in the form of a chemical reaction in terms of symbols, molecular formulas, moles, etc. We already know that all the elements and compounds are represented using certain symbols, like hydrogen is written as capital H, barium is written as Ba, helium is written as He, sulfuric acid is written as H2SO4. So using these formulas, we write the chemical equations also. So a chemical reaction consists of two parts, reactants and products. The part which is written on the left side of the arrow is called the reactants, and the part which is written on the right side are the products. That means reactants are those substances which react or undergo a chemical reaction to form something, and this something is called the product. For example, magnesium and oxygen, when they combine, they form magnesium oxide. Here we write this reaction as magnesium plus oxygen, where magnesium and oxygen are reactants, gives, which is represented by the arrow, magnesium oxide, and magnesium oxide is the product which is written on the right side of the arrow. So this forms the complete chemical reaction or the equation. Students, there are certain rules to write a chemical equation. First is that we need to use the symbols or the formulas, like in magnesium oxide equation we used Mg plus O2, which gives MgO. Or if we take an example of zinc and sulfuric acid, we write the equation as Zn plus H2SO4, which gives ZnSO4 plus H2. So we need to represent the chemical equation with formulas or the symbols. Second rule is that a chemical equation should be balanced. Now, what is a balanced chemical equation? A balanced chemical equation means that the number of atoms of each element are same on both the sides, that is on the left side and on the right side. Again, I would take the example of the same equation of formation of magnesium oxide. Mg plus O2 gives MgO. This was the equation. And if we want to find out that it is a balanced chemical equation or not, we would count the number of atoms of Mg and O on left side and on right side. So on left side magnesium is 1 and on right side magnesium is 1. So that is balanced. Now if we look at oxygen, O2 on left side and on right side it is O. So no, oxygen is not same on both the sides. So this is not a balanced equation, and an unbalanced equation is called a skeletal chemical equation for a reaction. Here I would like you to recall the law of conservation of mass, which you studied in class 9. So according to which mass can neither be created nor destroyed in a chemical reaction, which means the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. So if we follow the universal law of conservation of mass, we need to balance a skeletal chemical reaction. So now we need to learn how to balance a chemical reaction. First step is to write the skeletal equation or unbalanced equation using the chemical formula or the symbols. Now write the number of atoms of elements present in the reactants and in products in a table. For example, here we will take the example of an equation between iron and water. That means Fe plus H2O, which gives Fe3O4 plus H2. Now if we write the number of atoms of reactants and products, we get that iron in reactants is 1, hydrogen in reactants is 2, oxygen is 1, and in products, as the product is Fe3O4 plus H2, iron is 3, hydrogen is 2, oxygen is 4. Now the third step is to balance the atoms, which is maximum in number on either side of the chemical reaction. In this equation, the number of oxygen atom is maximum on the right hand side. Now to balance the oxygen, we need to multiply the oxygen on the left hand side by 4. so that the number of oxygen atoms become equal on both the sides. So now we multiply 4 into H2O. But now the number of hydrogen atoms become 8 on the left hand side, which is more than that on the right hand side. We have to balance it. To balance it, we need to multiply the hydrogen on the right hand side by 4. After doing this, the number of oxygen and hydrogen atoms become equal on both the sides. The number of iron is 1 on left hand side while it is 3 on right hand side. We have to balance this also. To balance it, we multiply the iron on the left hand side by 3. What we get is the number of atoms of each element are now equal on both the sides. Thus, this equation becomes a balanced equation. So finally, what we get is 3Fe plus 4H2O gives Fe3O4 plus 4H2. In this equation, all the atoms are balanced on both the sides. Let me give you another example of propane. Propane is C3H8 and it reacts with oxygen O2. It gives CO2 plus H2O. This was the skeletal equation. Now, if we want to balance this equation, first we need to write the number of atoms in left hand side and the number of atoms on right hand side in a table. Here I would like you to pause for a while and write the answers in your notebook and then again listen to the answer. So let me give you the answer also. Number of atoms of carbon on left hand side is 3, C3H8 it is. Hydrogen is 8 and oxygen is 2. On right hand side, carbon is 1, that is in CO2. H is 2 in water, H2O. And oxygen is 3 because we have CO2 also and H2O also. So it is 3. So firstly we balance the hydrogen, which is 8 on left hand side and only 2 on the right hand side. To balance this, we multiply 4 on the right hand side, which makes 8 hydrogen on both the sides. If we look at carbon, carbon is 3 on left side and only 1 on right side. So on right side in CO2 we multiply 3, which balances carbon on both the sides. We are left with oxygen O2. Oxygen on the right hand side has become 6 plus 4, that is 10, because we have multiplied 3 to CO2 and 4 to H2O. And on the left hand side it is only 1. So 2, it is not 1, it's 2, O2. So to balance this, simply we multiply O2 with 5. On left hand side also it is 10 now, and on right hand side also it is 10. So finally what we get is C3H8 plus 5O2 gives 3CO2 plus 4H2O. Now the equation is balanced. Let me also discuss a few examples from the NCERT questions. Hydrogen plus chloride gives hydrogen chloride. This equation is H2 plus Cl2 gives HCl. On left hand side, H2 and Cl are 2, and on right hand side it's 1. So simple balancing, on right hand side we multiply HCl by 2. Another equation is sodium plus water gives sodium hydroxide plus hydrogen, that is the skeletal equation is Na plus H2O gives NaOH plus H2. So on right hand side H is 3 and on left hand side H is 2. Always remember that we try to make the number of atoms even in number instead of odd. 3 is odd number, which is the number of hydrogen on the right hand side. So on left hand side we multiply H2O with 2. When we do that, number of hydrogen atoms on left hand side becomes 4 and on right hand side it's 3. So we again need to balance on right hand side. To overcome this problem, we multiply sodium hydroxide or NaOH with 2. Now the number of hydrogen on left hand side and right hand side both are 4. But on left hand side, sodium is less, that is 1, and sodium on right hand side is 2. So to balance this, we multiply Na on left hand side with 2. Now the equation is balanced, and the final equation we get is 2Na plus 2H2O gives 2NaOH plus H2. Sodium on left hand side is 2, atoms of hydrogen is 4, oxygen is 2 as it is 2H2O, and on right hand side we have 2NaOH plus H2, so sodium is 2, oxygen is 2 and hydrogen is 4. The last rule for writing the chemical reactions or equations is that we need to write the symbols of physical states. For liquid state, we write small l. For solids, we write small s. And for gaseous, we write small g. For aqueous state, we write AQ in small. The word aqueous is written if the reactant or the product is present as a solution in water. So let me take an example here. The reaction Fe plus H2O gives Fe3O4 plus H2 will be written as, with the symbols of physical states, will be written as Fe bracket small s plus H2O bracket G. For gaseous state, it is in vapor state here, gives Fe3O4 bracket S for solid plus H2 bracket G for gaseous state. Usually the physical states are not included in chemical equation unless it is very necessary to specify them. Sometimes the reaction conditions like temperature, pressure or the catalyst etc. for the reaction are also indicated above or below the arrow in the equation if it's needed. So students, I hope the next time you write a chemical equation, it will be balanced and you will follow all the rules you learned today. Take care of yourself and keep working hard.